We are looking at beginning our APEX first trimester project, modeling real world data and analyzing it and discussing it and putting it in context through our calculus understanding of rates of change and descriptions of functions and all of the work you've been doing in this most recent unit. So I'm just going to show you kind of how to get started working with some data using Desmos. So this is a basic description. This will probably change over time as I refine it. So if you're not in 2024 right now, this is maybe a little bit old, but it'll still be relevant because you'll be looking at data sets and doing the following. So you see here is an introductory video on where I first learned or how I first learned to work with Desmos and Data. Now I'm doing it a little bit more tailored for you guys. So we can start here on the data sets. This is the one that I'm using in this demo purpose. You don't have to use this one. I'm asking you to use the other three, but this is a good place to start. So I double click on that and you'll see I open up the file. It's a little bit off screen. I think I can drag it back on. There it is. And so then I can just select this data. Now this is supposed to be the first 12 days after a major rainstorm event, a hurricane, like in the Gulf of Mexico where the water is salty, but a lot of rainwater can wash that out and dilute it. So this is the salinity levels in PSU, which is kind of a little bit arbitrary way of measuring the amount of salt in water through, I think, electrical conductivity. So it's not like parts per million or something like that, PSUs. So I'm going to copy that, and then I'm going to go to Delta Math. Delta Math starts with a D. Desmos I'm talking about. I'm going to drag this a little bit more over here. Whoops, I want to be able to see all of this equation bar. It's all right. I'll maybe make this a little bit smaller and I'll drag this over. We should be able to make this work. Okay, so all you do is you click on that and you've copied that data, and then I just paste it in and there it is. Okay, notice this little dialog up here. It's saying it's zoomed to fit your data. Thank you very much, Desmos, for doing that. It makes our life so much easier. It, it could be in the thousands on one axis or the other, and so it has automatically adjusted this to make it kind of fit in our window. Okay, so these are the salinity data points, and this is each day, I think at noon after this event. All right, so what I'm going to do is I'm going to find a simple model that will fit that. I think most of you guys are familiar with the linear model, so this is how you're able to do it on Desmos. I'm going to type in y and then hit the number 1, and it automatically puts it down there as a subscript. Okay, now we're used to equations being equal, but this is a regression, and the way you tell Desmos to do this is you hit the shift button and then go the one key to the left of the number 1 up at the top left, and that gives you the tilde. That is telling this application that you're looking for a regression equation. We're going to do mx plus b, so I do m, and then I do x1, and then plus b. And you'll look up here, the data is, that's x1, that just means each one of these, x1, then x2, then x3, then x4, and so on with y1, 2, 3, and 4. And this is the way we get the computer to do this regression line. All right, so you can see that's, it's reasonably approximating this, but not very good. And especially if you think about what's going on in the physical world, there's no reason to believe that as the salt water kind of comes back to resalinate, that it would somehow keep going up and up and up and up and up afterwards. So maybe we could think of a little bit better model. So I'll turn that one off, and you could see if you can take this idea just on your own now and get a quadratic model. All right, so a quadratic model is typically y equals ax squared plus bx plus c, and I will just replace the x's and the y's with the subscripted variables. So I'm going to do y1, and then instead of equals, I'm going to do one keystroke to the left of 1, the tilde, and then I'll do ax1, and then above the 6, I'll shift and hit the 6 key, type a 2. You don't even have to arrow to the right. If I just type plus, it knows to jump it down, and then bx1, and then plus c. And there is our quadratic fit. And you see that's actually pretty good. That's actually quite close. But if you think about it again, there's no reason to think that this would be a really good long-term model, because why would the salinity immediately drop after it's raised up to kind of its normal level? So if you know your curves, one that should perhaps spring to mind is what's called the logistic curve. I believe you guys have all studied this. This is where we might have a population reaching a carrying capacity, or in this case, salt rising to a sort of a baseline level, an ambient level. So I will then show you how to type in a logistic function. If you look it up on Wikipedia, or if you know it from your work last year, basic template is, and I'll type this in with equals and then fill it in later, maybe y equals, and then usually they use a capital M in many textbooks, and then over 1 plus, and then a lot of times it's a capital A, and then E, and then raised to the minus KT. That's a basic template. And what this means is, like I said, the M is the amount of salt in water in the ocean, or whatever this area is, when it's just like normal and not diluted. And then if you think about, as you go into the future, as time gets larger, that minus KT is going to bring this whole thing down to 0, and you've got M over 1, and that is the level you'd expect it to find an equilibrium over time. The A value is a bit complicated for us now. We'll talk about it again when we get to differential equations, but that's just kind of like not an initial amount, but it represents that a little bit. And then the K is like the rate of increase or decrease. All right, so that's going to be something that is a variable. So I'm going to go back and I'm just going to redo this with the tilde right there, and then I'm going to just use A because I am not confident that capital letters work. You can test this out though. I'm going to do shift, whoops, I'm going to do divide, and then I'm going to do 1 plus, and then I'm just going to use B, and then I'm going to type E. It knows what E is, and then I'm going to do caret to the minus, and then I'm going to use K, and I'll use C, and then X sub 1, okay? And why does it not like that? Let's see what the problem is. Y may not be used. Oh, that's because I need to do Y1. So I thought I typed it. There we go. Okay, so there is my logistic curve, and it looks kind of like it makes sense that it's maxing out at that amount. It takes only 12 days, and perhaps at the very worst part of the storm, there was some data that we didn't get down here. In this case, that might be if somehow the ocean was walled off and it started only fresh water. Unlikely, not very realistic, but that would be perhaps how it would fill initially very quickly and then max out. Okay, so that's a logistic curve. What I want you to do for your homework is to do exactly what I'm doing. Bring in the data, think about the data, see if you can find the right model that will work, and then be ready to discuss things that have come out of section 4.3. I want you to be able to talk about concavity, maximum points, minimum points, inflection points if there are any good vocab that you can work in to describe how well your functions model the data that you can find there. Okay, thanks so much everybody. Have a good weekend.